Okay, so hi everyone, Senan this side, and in this video we are going to solve this stone game problem. And I just saw this problem and I found this to be too easy, so I don't think this is worthy of a medium level problem. So basically you have Alice and Bob. They are playing a game with a pile of stones. There is an even number of piles arranged in a row, and each pile has a positive integer number. Stones, piles of 5. The objective of the game is to end with the most stones. The total number of stones across all the piles is odd, so there are no ties. Alice and Bob take turns, and Alice starting first. Each turn, a player takes entire pile of stones either from the beginning or from the end of the row. This continues until there are no more piles left, at which point the person with the most stone wins. Assuming both play optimally, return true if Alice wins the game or false if Bob wins. Okay, so this is a sort of a greedy approach, I think, because let's say if 5, 3, 4, 5 is our sample input and Alice moves first. So what Alice does is takes the pile with the maximum numbers of stone. Now what we are left with is 3, 4, 5. Now it's the turn of the Bob. So he checks 3 and 5. He sees 5 is the most on the edges. 5 has the most, or basically the last pile has the most number of stones, which is 5. So Bob also takes 5s. Now we are remaining with this 3 and 4. Now it's the turn of Alice. What does Alice do? She takes the stone with the most number of stones. Okay, sure. So she takes the pile with the most number of stones, so which is 4. And in the end, Bob has only one option to take, and he takes 3. Okay, so that's basically a greedy approach, and we use a 2-pointer approach. And since we know that the length of piles is even, and since sum of all elements is odd, so there is no checking of time. There would always be a winner, and piles dot length is even, right? So this is actually helpful while writing the code. It would simplify the checking condition. So let's take the 2 pointers. Int I is 0, int j is equal to piles dot size minus 1. Let's take the players. Int players of size, rather than I prefer using vectors. Int players of size 2 and initialized with value 0. Okay, now let's int p. P signifies the person who is playing. Let's say 0. So 0 denotes Alice and 1 denotes Bob. Now what I do is while I less than j, I just check if piles of I is greater than piles of j. What you do is give this piles of the value stored in piles of I to the player who is playing. I'll say players of P plus equal to piles of I, and otherwise else players of P plus equal to piles of J. But after doing this, we know we cannot take this I or J again, so I'll do I plus plus and J minus minus. And after this, I'll say P is not equal to P. That means I change the player. If P is 0, now P will become 1. If P is 1, now P will become 0. And in the end, I return, like we need to return true if Alice wins the game or false if Bob wins. So I'll just say players of 0 is greater than players of 1. So if Alice has more points than Bob, return true, otherwise return false. And I think this is the whole code, and this is not at all worthy of a medium level problem. That is what I think. And just run this and see this is working correctly, and let's just submit this. Yep, B is 100%. What do you want more in this, right? So this works perfectly well. So basically, I used B is not equal to P to change the players rather than having two variables, Alice and Bob, and have four if and else condition just to check who the player is currently. Let's say if we have more number of players, we can have let's say we have n players rather than 2, we have n players. What I can do is P is equal to P plus 1, and then I'll just do modulo n, which is the number of players. That is the logic. Since we have 0 and 1, so I used P is not equal to P. And yep, that was the whole video about. Hope this helps. And if you found this video helpful, be sure to share it with someone you think would find this helpful. And yep, thanks for watching and bye.